Hi, this is Maggie from Design Code Debug Repeat. Welcome to the channel and to our 8th video in the Introductory R series. In the last two videos and this one, we're covering some programming features of R. In the last two videos, we talked about if statements and functions. In this video, we're going to learn how to write for loops in R. I have here our script from the last video, which I've renamed to loops.r. This script works with our AI data, a table of investments in different categories of AI research for the years 2017 through 2021. In the last video, we wrote a function called removeColumn that will remove any column from any data frame, if the column is in the data frame, and return the modified data frame. We used this function to remove the code column from our AI 2020 and AI 2021 tables. And now the problem is, this still requires me to call the function for all of the tables that I read in, even if there are hundreds of tables. So there is still potentially a lot of repetition, and repeated code, copied and pasted code, is not ideal for several reasons. It makes your script longer, and therefore it's harder to find the code you're looking for in the script. It makes the script harder to modify, because if you need to modify the file reading code, you have to modify it every place you're reading a file, and it makes it more prone to errors, as I illustrated in the last video, because you might forget to change something that needs to be changed in the pasted code. That's quite a common error. But luckily, this is the sort of repetition that can be conquered with a loop. A loop will make our code shorter, easier to modify, and less prone to errors. I've extracted all of the years of data from our original table into 5 different files we want to read in. To illustrate this common situation of multiple files we want to combine into one R data frame, I've put the 5 tables into a single folder called Data, in the same folder with my R script called loops.r. What a loop will allow us to do is open and read all of the files with just one block of code. A loop allows us to loop over a collection of something, applying an algorithm to each thing we loop over. We can loop over numbers, files, data frames, the column names of data frames, the names of files, etc. Anytime we can create a list or a vector or some other collection type of something, we can loop over it to apply an algorithm. The thing that we're looping over will feature in that algorithm. Now, there isn't very much looping in R, actually, which you might find surprising if you come from a programming background. You can loop over data frames and vectors, but you usually don't have to, because most operations in R apply to vectors. If I want to add 2 vectors, for example, I just add them. I don't have to loop over each element in each vector and add them together. If you're coming from a programming background, this will take a little getting used to. But sometimes you'll have to loop, so that is why we're going to look at the syntax and learn how to do it. I'm going to start with a relatively simple loop to illustrate. The syntax of a loop is for, open paren, individual thing in group of things, close paren. Then open curly brace, the repeated code, which will usually be happening to individual thing, and then close curly brace. So let's write a loop that generates and prints the names of the files in our directory. Each file is called AI_data_year.csv. So to generate those names, we need to loop over years that range from 2017 to 2021. To do that, I can write for, open paren, year in, and then here is where I put what I want to loop over. I want to loop over 2017, 2018, 2019, 2020, 2021. I can generate those values using seek. So I'll write seek, open paren, 2017, comma, 2021. And then close paren, open curly brace, enter. The close curly brace is put at the end of the for loop for me. And now I can write the body, the algorithm I want to apply to each element in my sequence inside the curly braces. I want to append that element in the sequence, which I have called year, into a string. I can use paste to combine elements into a single string. I'll print it so we can see the results. So I'll write print open paren, paste open paren. And then in quotes, data/AI_data underscore, close quote, comma, year, comma, dot CSV, close quote. And so the first time through the loop, that will be data/AI underscore data underscore 2017.csv. The next time through, it will be data/AI underscore data underscore 2018.csv, etc. until the last time when it will be data/AI underscore data underscore 2021.csv. Now, paste will add a space between each element that I'm pasting together, but I can prevent that by writing comma sep equals open quote, close quote, no space between them as the last argument to paste. Now let's run that and see if it prints the path to each of the files in the directory, the strings that we constructed with our loop. And it does. So using a loop, we can construct the paths to all of our files. This is because the only thing that's different in each file name is the year, and we can easily generate and loop over those years. Later in this video, I'll show you how to write our loop so we get the file names from the operating system. But this is an excellent way to illustrate a loop because we're looping over something very simple, a list of numbers. Now let's modify this a little. Instead of printing our path names, let's store our path names in a list. A list is a data structure in R that is similar to a vector. It's an ordered collection of values. If I want to add each path into a list, I'll have to first create the list before I start looping. So I'll call the list paths, and I'll write paths is assigned the value of list, open paren, close paren, before my loop. I'll want to add my first element at index 1 in the list. I will need to keep track of an index to do this. So I can use the value year to do this, subtract 2016 from each year to get the indices 1 through 5. Or I could change my sequence to generate 1 through 5 and add 2016 to each value to generate the year. But I think it will be simpler to understand if I just create a new variable called I. So under paths is assigned the value of list, I'll write I is assigned the value of 1. And at the end of the loop, I is assigned the value I plus 1 to increment it to the next index in the paths list. And then instead of printing my path name, I'm going to add it into the list at index I. That looks like paths, open square bracket, I, close square bracket, is assigned the value of our paste. This is how we index into a list. Let's run that. And we can see paths in our global environment, and it's the path to each of our files stored in a list. So at the console, if I type paths, open square bracket, to close square bracket, we get the path to the 2018 CSV file. Okay, so that's pretty cool. I now have a collection of the path names. Can I use this loop to read in the files? If we look at the code in non-looping form, and I'm reading in all 5 tables here, you'll notice that the path is different for each block. We've solved that. We know how to generate a new path each time through the loop. But the other thing that's different is the variable that we're reading the table into. To read in and store multiple data frames, we'll need to store them in a list, just as we are currently storing the path names in a list. So we'll generate the path name, and instead of storing the path name in our list, we'll store the table in a list. Let's copy our code that creates the list of paths and change it a little. We'll change the name of the list from paths to tables. We can temporarily read into a data frame called df. So df is assigned the value of read CSV, and then we'll pass in our paste code. Remember, that's the name of the next path to a file. And then we'll write df is assigned the value of remove column df code, and then we can store df in tables sub I. So this code is really quite similar, It's just that we're generating our path using the sequence, then reading in the table to a temporary variable called df, removing the column, and then storing df in a list rather than the path name. Let's run this and see what's in the workspace. Okay, there's a list called tables with 5 elements, and we open it up, and we see their tibbles. Let's look at one by typing tables, open square bracket, 2, close square bracket in the workspace. And we see the top of the 2018 table with the code column removed. Now, what if our tables aren't consistently named, and we just want to read in every file that's in the data folder? We can get the file names from the operating system using list.files. If I write just list.files, open paren, close paren, in the console, it produces a list of the files in the current working directory. That's my script, loops.r, and my folder data. If I write list.files, in quotes, data, then I get the list of files following that path from the current directory through the data folder, and I get the files in the data folder. Those are the files I want to open. And because it's a list, I can loop over them. So I'll copy my code and write this other loop below, so you'll have both versions. I'll write file names is assigned the value of list.files data. And then instead of looping over the years, I'll write for file name in file names. And let me change this list to be called tables2. Now, in a loop, we're looping over a collection of somethings, and for each something, we write an algorithm that works with it to do what we want to the collection. In this case, we are now looping over the file name. So we're going to read CSV and then the file name, but we're still going to have to paste the folder path to the front of it because file names just contains the names of the files in the data folder, and our working directory is above the data folder. So I'll write df is assigned the value of read CSV, paste data / file name, sep equals quote quote. And except for changing tables to tables2, I can leave the rest. And let's run that code. And we can now see tables2 in the workspace. And if I look at tables2 sub 3, for example, in the console, we see it's the 2019 table or data frame with the code column removed. So this is very useful. We can get file names from the operating system and read them in. Let's talk briefly about the apply family of functions. These help us avoid writing loops in R. Let's see if we can accomplish the same thing, reading in data frames and applying our remove column function using one of the apply functions. The apply functions, apply, lapply, and sapply, will automatically apply a function to each element of a collection and return another collection. The different functions apply to different collections as input and produce different types of outputs. If we type $lapply in the console, we see that lapply applies a function over a list or vector and returns a list. We have a list of path names. Let's see if we can apply read CSV to our list of path names to produce a list of data frames. Notice the parameters to lapply are first the list or vector and then the function. So I'll call this new table tables3. So tables3 is assigned the value of lapply, open paren, paths, comma, read underscore CSV, and execute that code. Now, one thing to note, notice I'm not putting parentheses after read CSV. That's because I'm not calling the function here. I'm passing it as data to lapply. I know that's hard to get used to sometimes, even for people with some programming background. Functions can be treated as data. We can pass a function to another function to execute it. Now, in the workspace, I can see tables3. At the console, let's look at tables3 sub 1. And we see the 2017 data, but it still has the code column. We've read the table in, but we didn't call our remove column function. We can call that function with lapply too. So I'll write tables4 is assigned the value lapply, open paren, tables3, the table we just created, comma, and then remove column. Now recall that remove column takes another parameter besides the data frame. It takes the column we want to remove. So we can include that by using the name of the parameter. It's called call name. So back in our call name equals code. And let's execute that. And we can see tables4 in the workspace now. And let's look at tables4 sub 1. And we can see that the code column has been removed. Okay, this is a lot, I know. I think it's going to be useful to you to know how to write loops, but bear in mind that writing functions and using apply, sapply, or lapply might be the more typical way to accomplish what you're accomplishing in a loop, so they are worth studying and practicing with. I hope you found this helpful. The code, as always, will be uploaded to my GitHub repository with a link in the description. There are book recommendations in the description of this video, and you might look through the exercises in the books to find ways to practice. You could also practice by rewriting all of the different loops we wrote here, and then trying the lapply examples. Have fun with it.